Let's look at this next example. It says a man has a collection of stamps consisting of 5-cent stamps and 8-cent stamps. There are 3 times as many 8-cent stamps as there are 5-cent stamps. The total value of all the stamps is $3.48. The last part, which is where we define the variable, says how many of each stamp does he have? So what are the 2 types of stamps? There are 5-cent stamps and 8-cent stamps. Again, remember, if I say X is 5-cent stamps and Y is 8-cent stamps, that is incorrect. I need to define what attribute about the stamps I want to know. And the answer is how many. So in other words, this needs to say the number of 5-cent stamps and the number of 8-cent stamps. Then I have properly defined my variables. Okay, let's start filling in our table. So we have our 5-cent stamps, we have our 8-cent stamps, and we have our total. Those are the 3 things that we're curious about in this table. Okay, first we have the number of stamps. Okay, as you know, we don't know how many 5-cent stamps we have. We also don't know how many 8-cent stamps we have. But do we know the total this time? It doesn't look like we do. We do know that there are 3 times as many 8-cent stamps as 5-cent stamps. So how do we figure that out? How do we write that as an equation? Well, let's see. Let's try to make a chart. So there are 5-cent stamps, okay, and so this is X, and then there are 8-cent stamps. The number of 8-cent stamps is Y. Okay, well, let's see. It says there are 3 times as many 8-cent stamps as 5-cent stamps. So if I have 1 5-cent stamp, according to this, then I have 3 times as many of the 8-cent stamps. If I have 2 5-cent stamps, I have 3 times as many 8-cent stamps, or 6. If I have 3 5-cent stamps, I have 3 times as many 8-cent stamps, which is 9. So what if I have X 5-cent stamps? Well, then this is going to be 3 times X. So my other equation is actually that Y here equals 3X. Okay, so this problem is a little bit different. This is one of my equations. Okay, and again, we're not given a total. We can't put anything in this box. All right, let's fill in the rest of our table. So we have the number of stamps. We also have the value of the stamp. And of course, the 5-cent stamp is worth, shockingly, 5 cents. Be careful, make sure you use 0.05, right? Because it's not worth $5, right? It's worth 5 cents. Okay, same thing with 8-cent stamps. Again, it's not useful to add those together. That doesn't get us any closer to our solution. Okay, then we have the total value, or the total amount of money that's being tied up in each type of stamp. And you might recall, in previous problems, all we do is we just multiply across. So 0.05 times x is 0.05x. What about this? What should we do? Well, you have 2 options. You could do 0.08y, right? Or you could do 0.08 times 3x. I'll leave it up to you. Okay, so what information have we still not used? We've used this piece of information and that piece of information. We've used this sentence. What about the total value? We haven't used that. So the total value of all the stamps is $3.48. Okay, so I'm going to erase this down here so that we have some room. So my 2 equations are that y equals 3x, and my other equation is that 0.05x plus 0.08y equals $3.48. Okay, so these are the 2 equations for this problem. So now I can solve it in either way, substitution or elimination. To me, this problem looks like it's going to lend itself more to substitution because I have one variable that's already been isolated for me. So again, we have y equals 3x, and then we have 0.05x plus 0.08y equals, what was it? It was $3.48. Okay, so what's going to happen here is that wherever I see a y, instead of writing a y, I'm going to write 3x. Let me rewrite that so it doesn't look weird. I'm going to write 3x. Okay, so I have 0.05x plus 0.08 times 3x equals 348. Okay, so 0.05x plus 0.24x equals 348. Of course, those are like terms, so we can combine them. Then we can divide both sides by 0.29. And we find that there are 12 of these stamps. I think X was the 5-cent stamps. Okay. So now we have to find the number of the other sort of stamps. So remember, y equals 3x. So y is equal to 3 times 12, or 36. Okay? Then last but not least, we really need to check our work. Okay? And we just used the y equals 3x equation. Therefore, we have to use the other equation. Okay, so 0.05x plus 0.08y equals 3.48. So this gives us 0.6 or 60 cents plus 288. And of course, if you add those together, you do get 348. So this checks out. Okay, so last but not least, we need to write a sentence to explain what x equals 12 and y equals 36 means. So I can simply say that there are 12 5-cent stamps and that there are 36 8-cent stamps. Example 4, a woman invests $4,000 in 2 accounts, one with 6% interest and the other with 9% interest, for 1 year. At the end of the year, she has earned $270 in interest. How much did she invest in each account? Remember, the last part of this is going to tell you what your 2 variables are. So it says each account. Well, what are the 2 accounts? Well, there is a 6% account and there is a 9% account. Again, I encourage you to remember, if you simply do something like this, where you say x is a 6% account and y is a 9% account, that is incorrect. We need to know, what about the account do we want to know? Specifically, we need to know how much did she invest in each account. So we'll let x equal the amount invested in the 6% account and y be the amount invested in the 9% account. So let's jump down to our table. So we have the 6% account, the 9% account, and of course we have a total. So our first column can simply be the amount of money that was invested in each account. Of course, we don't know how much was invested in each account individually, so we can just use our variables that we just defined. However, we do know the total amount that was invested, and that was $4,000. All right, well, what else do we know? Well, we also know the interest rate. 6% written as a decimal is 0.06. 9% written as a decimal is 0.09. So what should our last column be? Well, we've used all of these pieces of information except for this last piece right here. It says that she earned $270 in interest. So the last column is the amount of interest that she earns. In other words, the amount of money that she has more than what she started with. So we know that the total amount of money that she ends up with, the total amount of extra money that she didn't have before, is $270. Then, like always, we are going to multiply across to find the other values. So the amount of money that she has from the first account is 6% of the amount she invested there, and the amount of money that she has for the other account is 9% of whatever she invested there. Again, the reason we go through all this work is because the equations just fall out. So we have x plus y equals 4,000, and then from here we have 0.06x plus 0.09y equals 270. Okay, so these are our two equations, and then we can go ahead and set about solving them. So we have x plus y equals 4,000. Again, that's the amount of money she invested. And then we have the amount of interest that she gets, and that is this equation here. Okay, again, you can use substitution or elimination, it doesn't matter. I think I'm going to choose to use substitution. So the first thing I'm going to do is isolate one variable. I'm going to do that by subtracting y from both sides of my first equation. That gives me x equals 4,000 minus y. So then I can put this expression in place of x. So instead of writing 0.06x, I'm going to write 0.06 times the quantity, 4,000 minus y. Then I'm going to distribute. So this gives me 240 minus 0.06y plus 0.09y equals 270. Okay, then I can combine these like terms. That gives me positive 0.03y. Then I can subtract 240 from both sides of my equation, and that gives me 0.03y equals 30. And then I can divide both sides by 0.03. And that gives me y equals 1,000. Okay. So now that I've found out that y equals 1,000, I need to use my second equation. This is step 3 here of substitution. I need to find out, well, what is x? Okay. So I have x plus y equals 4,000. Okay. So something plus 1,000 equals 4,000. You can probably guess what it is, or you can actually, do the algebra. And so she must have invested $3,000 in the other account. Okay. However, remember, it's very important to check your work because, as you can see, we've done a lot of it, and the more steps there are, the more likely we are, or I am anyways, to make a mistake. Okay. So 6% of 3,000 plus 9% of 1,000 should be, if we did this right, should be 270. Okay, so let's check our work and see if it is correct. Okay, so 6% times 3,000 is 180, and 9% of 1,000 is 90. Let's see if this checks out. Yes, so 270 equals 270, so that is correct. So let's write our sentence to explain what we've done. So we can say that she invested $3,000 in the 6% account, and she invested $1,000 in the 9% account. Example 5. John invests $5,000 in one account and $8,000 in another account that pays 4% more than the first account. He earned $1,230 in interest after 1 year. At what rates did he invest? Okay, so again, there's two accounts. For lack of a better descriptor, I'll just call them account 1 and account 2. Remember, if I just say x is account 1 and y is account 2, that is not correct, right? What are we talking about? Are we talking about the amount of money in the account? Are we talking about the interest rate in the account? What do they want to know about this account? Okay, and specifically it asks me for the interest rate. It says, at what rates did he invest? So what I need to write is I need to say that one variable is the interest rate of account 1. The other variable is going to be the interest rate of account 2. So again, we have account 1, we have account 2, and of course we'll have our total. Okay, so we can do these columns pretty much in any order. So let's do, I think this is what we did last time. We did the amount invested. Okay, so that we know that he put $5,000 in one account, and we know that he put $8,000 in the other account. You can add them together, but that's really not going to enlighten us or give us any more information, so we'll just leave that blank. Okay, then we have our interest rate. Well, what do we know about this? Well, we know that the interest rate of the second account is 4% more than the first account. How can I write 4% more? Well, let's just make some examples. So if my interest rate on the first account was 1%, well, what is 4% more than 1%? Well, that would be 5%. If the interest rate on my second account was 2%, right, and this is 4% more, that would be 4 plus 2% or 6%. So if this is X percent, right, this would be 4% plus X percent. So this is literally just X plus 0.04. Okay, so we don't know the interest rate of the first account, but we do know that the interest rate of the second account is the interest rate of the first account plus 0.04. So this is actually going to be one of our equations. Okay, so now we need to know how much money, right? How much money and interest did this person make? Okay, so we know that they earned $1,230, so we can put $1,230 for the total, right? And remember, just as always, we're going to multiply across. So we have 5,000x and we have 8,000y. Okay, so our two equations, one of them is y is equal to x plus 0.04. The other one is 5,000x plus 8,000y equals 1,230. Okay, so these are the two equations that we have. Now, one of the variables has already been isolated for us, so I would say that the easiest way to do this is to use substitution. So let's go ahead and do that. Okay, so if I'm using substitution, that means that wherever I see y in the second equation, instead of writing y, I'm going to write x plus 0.04. And then I'll just go back and fill in the equation around that value. Oops, make that an 8. 1, 2, 3, 5. Okay, so we have 5,000x plus 8,000 times the quantity, x plus 0.04, equals 1,230. So, of course, I'm going to use the distributive property here. This is 320. Okay, so these are like terms. I can combine them. This gives me 13,000x plus 320 equals 1,230. So I have 13,000x equals 910. Divide, get something that looks like that, and that gives us an interest rate of 7%. Okay, now we need to find the other interest rate. So if I look at my other interest rate, I know that my other interest rate is whatever that is plus 4%. So 7% plus 4% is going to give me 11%. Okay? And then, as always, we really need to check our work. So let's check our work using the other equation. Okay, so this is saying 5,000 times 7% plus 8,000 times 11% should give us $1,230. So let's see if that is true. So that gives us 350 plus 880 equals 1,230. And sure enough, that does work out. Okay, so now we can write a sentence to explain or to develop this idea of the two interest rates. Okay, so we can say that John invested $5,000 in an account that yields 7% simple interest and $8,000 in an account that yields 11% simple interest. Example 6. Jane invests her savings in two bank accounts, one paying 3% and the other paying 5% simple interest per year. She puts twice as much in the lower yielding account because it is less risky. Her annual interest is $2,200. How much did she invest at each rate? Remember, the last part of the word problem tells us what our variables are. So we have two accounts, one that yields 3% and one that yields 5%. Remember, if we define our variables like this, that is insufficient. What aspect of the account do we care about? Do we want to know how much money is in the account? Do we want to know the interest rate? What is the variable representing? So we need to add some information. This says how much did she invest at each rate. So we need to know how much money was invested in each account. So we can say that X is the amount invested in the 3% account and Y will be the amount invested in the 5% account. Now our variables have been appropriately defined. So we have a 3% account, we have a 5% account, and of course we'll have our total. Okay, so we'll have the amount of money invested. And of course, as you know, we don't know how much money she invested in each account. However, do we know how much she invested total? Oh no, we don't know that either. Well, what do we know? We know that she put twice as much into the lower yielding account, meaning the 3% account, because it was less risky. Let's see if we can make a table that makes sense of this. Okay, so this is the 3% account, so we'll call this X, right? And this is the 5% account, Y. All right, so let's see. So it says she puts twice as much in the lower yielding account. So the lower yielding account is going to have more money. So if she puts $1,000 in the lower yielding account, that is twice as much as the 5% account. So she only put $500 in the 5% account. Another way to think about it is if she put $1,000 in the 5% account, that means she put twice as much as that in the lower yielding account. So that means she put $2,000 in the lower yielding account. Likewise, if she put $2,000 in the 5% account, then she would put twice as much in the 3% account, or $4,000. So what's the pattern here? Can you see a pattern? So if this is X and that's Y, we can say that Y, if this is Y, the pattern is that as we go from this column to this column, we're multiplying by 2. So 2,000 times 2 is 4,000. So that means that X is 2Y. You could also say, of course, in other words, like if you divide it by 2, you could also say Y is equal to 1/2 X. They're equivalent expressions. So I'll leave it up to you how you would express that. For me, I'm just going to say that X equals 2Y, and that's going to be one of my two equations. Okay. So we have the amount invested, of course, then we need to know the rate at which everything was invested, and that's given to us. We know that this is 3%. We know that this is, 5%? Okay, and of course we could add them, but that's not really going to give us any other information. Okay, going back up here to the word problem, the only information we've not used yet is the $2,200. That is the total amount of interest that she's earned. So that's the $2,200 right here. Okay, and again, we can multiply across to fill in these boxes. So this is 0.03x, and this is 0.05y. All right, so now we need our two equations. So let's erase this so that we have room to write our two equations. So we've already said that one of our equations is x is equal to 2y, and the other one comes from the last column, 0.03x plus 0.05y equals 2,200. Okay, so now we can use either substitution or elimination to solve them. So we have x equals 2y, and then we have 0.03x plus 0.05y equals 2200. Okay. Again, as I pointed out, we already have x all by itself, so I am going to replace x with 2y in this other equation, and then solve for y. Okay, so this is going to give me 0.06y plus 0.05y equals 2200. I can combine them because they're like terms. That gives me 0.11y or 11% y equals $2,200. So we find out that y is equal to $20,000. Okay. So now I need to find x. Well, we already know that x is equal to 2y. So 2 times $20,000 is $40,000. Okay, so according to our work, she invested $20,000 in one account and $40,000 in another. But of course, as always, we really need to check our work and make sure that no mistakes were made, because it's very, very easy to make mistakes here. So we're going to have 3% of 40,000 plus 5% of 20,000. Okay, and if that is right, it should add up to $2,200. So let's see. So this is 1,200, and this is 1,000, and $2,200 equals $2,200. So that's correct. Okay, so let's write a sentence to express our answers. So we can say that Jane invested $40,000 in the 3% account and $20,000 in the 5% account.